Consider the subtleness of the sea, how its most dreaded creatures glide underwater, unapparent for the most part, and treacherously hidden beneath the loveliest tints of azure. From Moby Dick by Herman Melville. The architecture that make up today's large language models are made up of varied arrangements of neural networks. While we can clearly see the inputs and the outputs, what happens between the two is not so transparent. These hidden layers are the inner mechanics of how generative pre-trained transformers work so well. But what makes them so mysterious that even the developers can't understand it? What are the implications of this lack of transparency and the unsolved interpretability problem? Join me as we explore the black box of AI and why some experts are concerned. When I wake up in the morning, I grind my espresso beans, put them in a portafilter, and hit a button. As I watch the shots pour, I can comprehend the input and the output. But how did the water in the coffee grounds become the espresso shot? What happened inside the machine? This is the concept of a black box, a straightforward input and output. But unless I can look inside, I don't really understand what's going on under the hood. Artificial neural networks are mathematical models inspired by the biology of human and animal brains. They're made up of a series of layers of a number of nodes or neurons. In a large language model, your input is converted to tokens. Then the embedding process creates a vector representation of that token. It then performs a linear transformation on that data, applying weights and biases to it. Next, that data is passed on to the hidden layers. Again, weights and biases are applied through linear transformation. But then something else happens, a nonlinear transformation. Commonly, you'll find rectified linear units as the activation function in these hidden layer neurons. The function is nonlinear. There's a bend. Its shape and position is decided by the weights and biases of that neuron. By combining lots of these neurons together, you can get something entirely different, a piecewise linear approximation of a high-dimensional function like a sine wave. But how does the network even know how to combine the neurons to make these? When a neural network is being trained, it's given both the question and the answer. When the data is done being transformed by all the neurons in each layer of the network, the answer it gets at the end is compared to the solution provided by the training data. The difference between the two, or the loss, is backpropagated. Its gradient is calculated using the derivative of each neuron's activation function. Thereby, all the weights and biases of the network are adjusted. This complex process of calculations can yield some amazing results. Backpropagating changes to the network based on training data imbues the neurons with complexity. It allows them to work together, abstractly arriving at the right answers. Researchers are currently developing tools and techniques in an effort to better understand these inner workings. There are even some networks built from the ground up to be more understandable, but there is a performance trade-off. This interpretability problem raises some serious concerns. Let's consider the areas that AI is expected to greatly impact, like healthcare, finance, and autonomous vehicles. These domains carry significant potential for risk if an AI model were to act in an unexpected manner. As we become dependent on AI, the hidden layers of the model will be like the source code that runs society today, except no programmer wrote it. The AI learned it in a way that we can't yet fully understand. How can we trust that it will be fair, accurate, and unbiased, especially given its tendency to hallucinate wrong answers? This will be the subject of many debates in the near future. Government legislation and regulations will play a role. Geopolitics will also have an influence on how this technology is adopted globally. Can we afford to stifle its growth while others elsewhere will push forward? Is it wise to accelerate so quickly? The future of artificial intelligence is unclear, but if one thing is certain, it is its massive potential. It's not certain whether the acceleration of progress and growth in this area will continue at the same rate, but now is a good time to stay informed and to learn. If you want to join me as I try to understand this technology and the impact it may have on society, please click subscribe.